Alright, I'm going to start off by doing a couple general rules regarding exponents. And then we're going to get into the Chapter 5a review here. So, first thing, I just want to talk about some of these rules. So, like, one of the main rules that you're going to see is product of powers. So what that means is if you multiply two things together, so say like a to the n times a to the m, okay? If the bases are the same, meaning it's a and a, you're going to add the powers, okay? So that's going to be something that you're going to see. You often see this when you take like x squared times x to the third. You know, you get x to the fifth, something along those lines. The other thing you might see is a power to a power, where you got a to some power in parentheses raised to another power. In those situations, you multiply the powers. Okay, so just general rules here. The other thing you might see is if you have multiple things, say like a, b to some power, inside the parentheses, you can distribute that power to each thing inside the parentheses. Okay, and be careful with that property because a lot of times students want to distribute the n across a plus sign, and you can't do that. If it's a plus b to the n, you have to take a plus b times however many times n, or whatever number n is. If it's like a plus b to the second, it'd be a plus b times a plus b. So don't get confused. So don't distribute that. Okay. Another thing that you're going to see is like a to the negative n power, for instance. Negative powers are typically not accepted, so you want to make sure that you turn those into positives. And the way you do that is by taking the reciprocal, and then when you take and put that a to the negative n and put the power on the bottom of a fraction, or the denominator of a fraction, will become positive. And it works the opposite direction too. Like, so for instance, if you had 1 over a to the negative n, you can make it positive by pulling it to the top. Okay? And kind of going along the lines of product of powers, if you take a to the n over a to the m, then that would equal a to the n minus n. So you're going to subtract, you know, the bottom power from the top power. And it's just some quick, real quick recaps of some things that you probably already know. All right. Now that we've done that, we're going to look at some examples from your review and look at a couple illustrations of these properties. So for instance, if I look at question, say 3, looks like a pretty good illustration of a lot of the properties of exponents. You see a lot of product of powers, power to a power. So the first thing I'm going to do is I see this power outside, I'm going to distribute it to each term inside, just like we said as one of the properties. So the first term I'm going to leave alone. And the second one, I'm going to take x to the fourth to the third. Well, power to a power, you multiply. So it's 4 times 3 is 12. And then y to the negative 3 times 3 is y to the negative 9. All right, at this point, you got product of power. So it's x to the negative 2 times x to the 12th. So that's going to add the powers. So it's negative 2 plus 12. And then y to the 5th times y to the negative 9 is going to subtract the powers, or add the powers again. But again, it's going to be 5 minus 9, or 5 plus negative 9. And give me negative 4. Again, can't have negative powers, so the x to the 10 is fine, it's going to stay. But the y to the negative 4 comes to the bottom, and then now you have a proper exponential expression. So that's just something to look out for. A lot of properties at play there. The next 3 are good questions, combining like terms, distributing. I'm going to look at number 6, because if you can do number 6, I pretty much can do number 4 or 5. So number 6 is x plus 2 to the third. So again, here's like an illustration of what I was talking about. Do not, please, somebody's going to do this, I'm sure half my students will, but do not distribute that 3. Okay, that's going to be the most common error. Do not do that. That is not what you do with x plus 2 to the third. You can't do that because it's x plus 2. If it was x times 2, yeah, distribute the 3 all day long. Okay, but you have to realize there's a difference between x plus 2 and x times 2. In this case, it's x plus 2 to the third. So essentially what you do is you multiply x plus 2 3 times. Well, in order to do this, I'm going to multiply 2 of them together, and then I'm going to do what I call double distribute. Your teacher might call it something different, but when I multiply x plus 2 times x plus 2, I FOIL. That's going to give me first It's give me x squared. Outer, inner are 2x and 2x, so I add those up already in my head. Give me 4x plus 4. All right, if you don't see what I did there, just take the time, FOIL x plus 2 times x plus 2, and then you'll see what you do. All right, here's where the step that maybe is a little bit different comes into play, and this is what I call double distribute, where you take the x and you multiply it times everything inside the second parentheses. Second thing, you take the 2 and you multiply it times everything in the parentheses. So then I get x to the third plus 4x squared plus 4x for the first thing. I distribute this. And then I got 2x squared plus 8x plus 8. So now I combine all my like terms. I got 1x to the third. I got 4x to the second plus 2x to the second will be 6x to the second. I got 4x and 8x is 12x. And then I got 8, which is by itself. So that is a perfect example of when you want to double distribute. It's a little bit tricky, but overall very doable if you take your time. And then if you look at number 5, it's kind of like the same thing, where I'm going to distribute the x to everything, and then I'm going to distribute the 4 to everything, and I'm going to combine my like terms. All right, so couple examples of some things there, illustrating some of the things we were talking about. The last part of page 1 of your review deals with 2 functions, and you have to perform some indicated operations. Okay, the big thing that I think students have trouble with, and I'm going to look at 10 and 11 here, are when you take f of g, and again I said f of g, you have to remember that you're not multiplying the functions together. In fact, you're going to take and you're going to plug one of the functions in. So essentially when I take f of g, what I'm doing is I'm taking out this function g and I'm putting it in for x right here in f. So f of g of x, if I could write it out, is going to equal f of 3x plus 5, okay, which is going to give me, well, f of x is 8 minus x, so f of x is 8 minus x, so f of 3x plus 5 would be 8 minus 3x plus 5. So essentially, all I do, like I said, was if f of x equals 8 minus x, then f of 3x plus 5 is going to equal 8 minus 3x plus 5. And that's going to be the way you do it. So altogether, that gives me 8, distribute minus 3x minus 5. So it's going to be 3 minus 3x altogether. Okay. I also said we look at number 11, f of g of negative 1. Well, now that I know f of g of x, I can just plug negative 1 in there. So I want to look at 12. 12 is a little bit more interesting. But you hopefully can see all you got to do, f of g, you take g of x and you just plug it in for x in f. All right, for number 12, it says g of f of 2. So once again, I want to look at g of x and f of x. So just for reference, g of x is 3x plus 5, f of x is 8 minus x. So g of f of 2, off to the side, here's how I teach to do it. I'm going to take f of 2, okay? Since f of x was 8 minus x, this is going to be 8 minus 2, which is going to be 6. So now this is no longer g of f of 2, this is g of 6, okay? So now what's g of 6? Well, since g of x was 3x plus 5, g of 6 would be 3 times 6 plus 5. So that's 18 plus 5. So the answer to this question is 23. So don't panic when there's a number. Just take it work inside out. You're going to take f of 2. Once again, once you know f of 2, you simply just plug that in. So f of 2 is 6, so now it's g of 6. Now you look and say, okay, well, what's g of x? Well, g of x was 3x plus 5, so g of 6 would be 6 plus 5. 3 times 6 is 18 plus 5. Alright, so here's page 2 of your review. The first thing I want to talk about is tips for doing inverses. Inverses are found by switching x and y and then solving for y in a new equation. And not every function has an inverse, okay? So if it doesn't have an inverse, it's not abnormal. It's just, sometimes they don't. Factoring, you got to look for GCF, difference of two squares, MAF, and the sum of difference of cubes. So I want to give you that formula real quick. The sum of difference of cubes, if you got like x cubed plus y cubed, all right, then you have to figure out, first of all, we'll talk about it, but we got to figure out what to the third power makes x to the third. In this case, it's just x plus y. And then the second set of parentheses, it's x squared minus, you always change, again, if you could look, this sign and this sign will always be opposites. So x squared minus the product of x and y, and then I'm going to add y squared. Okay, and the same goes for x cubed minus y cubed. It's almost identical, except for the signs are flipped. So instead of x plus y in the first parentheses, it's going to be x minus y. Instead of negative xy, it's positive xy in the formula. So if you didn't know those formulas, there they are. You could pause, come back, and when we look at the problems in this section, you hopefully won't have too much trouble. So let's take a look at some of these problems. We'll look at an inverse question, and we'll look at a couple factoring questions. But inverses, verify that they are inverse. I'm going to look at finding inverses. So for 15, how do you find an inverse? Well, the process which we said, you start by calling this y, and then you flip x and y. So I'm going to take y and it becomes x, and x becomes y. It's like inverting it. So you're going to change your x values to y and your y values to x. So I'm going to solve for y now. So I'm going to subtract 8. Okay, x minus 8 equals negative 5y. And divide by negative 5. And altogether, my inverse y ends up equaling 8 minus x minus 8 all over negative 5. So I could rewrite this as f inverse of x, or f to the negative 1 power x, equals x minus 8 over negative 5. So that would be the inverse function of the function that was given. So that's how you find an inverse. Very simple process. Like I said, if you miss something, just go back, rewind, watch the process again. But the big step is right here. It's just switching x and y. Okay, once you do that, you solve for y, and the result is your inverse. So, moving along, we're going to look at some factoring questions. Like we learned a couple chapters ago, when you factor, or last chapter actually, when you factor, you got to check out how many terms there are. So typically, when you factor, there's going to be 2 terms, like there are here, 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 here. 3 terms, like there are here, here, and here, or 4 terms, okay? Each number of terms tells you you're going to do something differently, okay? So 2 terms, you're looking for a difference of 2 squares, you're looking for difference of sum of cubes, you're looking for GCF, okay? For 3 terms, you're looking for GCF, you're looking for MAF, all those kind of things. So we'll do one of each, okay? With 2 terms, I'm going to look at number 20, okay? So my first step with number 20 is to take out a greatest common factor, and I see that between x to the 5th and 216x to the 2nd, my greatest common factor is x to the 2nd. When I take that out, let me just erase this so I can get a little bit of room, but when you take out x to the 2nd, essentially what you're doing is you're dividing both terms by that x to the 2nd. So that gives me x to the 3rd plus 216. All right, at this point, I'm not done, because you see that x to the 3rd plus 216 is the sum of cubes. So at that point, you have to recognize, well, I'm doing the sum of cubes, so now I got to continue factoring. So these problems are a little bit more involved. They take some time. So now I got to rewrite this and say, well, what to the 3rd power makes x to the 3rd? Okay? And what to the 3rd power makes 216? So I'm going to rewrite it and say, well, x to the 3rd makes x to the 3rd, and then 6 to the 3rd makes 216. So now I'm just going to follow the pattern. Okay? Now my x, or my a and b, if you want, however you remember the formula, but the 2 numbers are x and 6, so I'm just going to go ahead and do my form. So it's x squared stays out front. Now it's x plus 6, x squared. I'm going to change this sign, and this sign are going to be opposites. So I'm going to take that was plus, now it's minus. Now all I do is multiply this term and this term, and get 6x. And then I take and add 6 squared, which is 36. So the total solution to this question is right here. Okay, so when you do difference in sum of cubes, you got to make sure that you end up with two terms in your first expression, and then 3 terms in your last expression. Okay, so that's a sum of cubes problem. Nothing too crazy there, but again, 2 terms. You got to look out for difference, sum and difference of squares, not the sum of squares, but difference of squares, or the sum and difference of cubes. Okay, Let's look at number 18. 18 has 3 terms. So when you see 3 terms, what do you look for? Well, probably MAF. Okay, probably something where I can take out a GCF here. In this case, it looks like 5x comes out. I take a 5x out of everything. You're left with a quadratic. So 5x out of 5x to the third is x to the second. 5x out of x, 5x squared is x. And then 5x out of 30x is 6. So now I'm stuck and I'm saying, okay, what multiplies to 6 but adds to 1? Okay, so in this particular case, if you're trying to factor this, you're like, okay, so what multiplies to 6 but adds to 1? Okay, so again, I'm factoring this part inside. I'm not worried about the 5x. Took that out. I'm going to leave that out. So what multiplies to 6 but adds to 1? So I'm thinking about what multiplies to 6. I'm thinking 2 and 3. No, those don't add to 1. Those add to 5. -2 and -3 add to -5. So if there's no factors, then this can't be factored. And this answer here is your fully factored answer, okay? So as far as this is concerned, you don't have to go ahead and do a quadratic formula or anything like that. It's not asking you to find x, it's asking you to factor. And if you can't factor, you can't find any f values, which in this case you cannot, then you're done factoring. All right, and then last thing you want to talk about, is when you have 4 terms, okay? When you have 4 terms, you should always think group 2 and 2 together, okay? So 4 terms, this is your typical process, okay? I see 3 terms, I think MAF. I see 2 terms, I think difference of 2 squares, or difference or sum of cubes. When I see 4 terms, I think group. And you group 2 and 2 together and take the GCF out of both. So it's 4x squared. Okay, when I take a 4x squared out of these, I get x minus 2. Here, I'm going to take out a 3 and get x minus 2. And here's your checkpoint, okay? If you grouped and did the process correctly, these 2 things are going to be the same. And at this point, you have 1 extra step. And now there's your GCF. So I could take that out again, out front. And when I divide both terms by x minus 2, I'm left with 4x squared plus 3. Okay? And that's it. There's nothing else you can do. I can't break down 4x squared plus 3 anymore. And that's all I can do. So a little bit of review of inverses, a little bit of review of factoring. Hopefully that helps you a little bit with the second page of your review. All right, for this last page, I just want to talk a little bit about how to identify degree, the type, the leading coefficient, describe the end behavior, because those are all important things as far as polynomial functions are concerned. So if I look at problem 26 here, there are a bunch of things it asks me to do. Number 1, it says state the degree. The degree is your highest exponent, okay? And the degree, if you're finding zeros of a function, the degree typically tells you how many zeros you're going to have. So in this particular case, degree is 4 because the highest exponent is 4, okay? The next question was, what is the type of function it is? It would be a polynomial. So if you ask you for type, if there are 2 terms, it's a binomial. 3 terms, a trinomial. Anything more than 3 terms is simply just referred to as a polynomial. First thing is, like, to decide whether the function is a polynomial function. I kind of skipped that. A polynomial function are any functions that have x's with powers, okay, other than whole number powers, okay? If you have square roots, it's not a polynomial function. If you have x's on the bottom of fractions, it's not a polynomial function because it would be negative powers. But if they have all positive whole number powers for x's, then you know it's a polynomial function. That's a typical polynomial function. That, looking at the next one, these are both polynomial functions. So basically the idea is just what is the degree, type, leading coefficient, and behavior, stuff like that. So what is the leading coefficient? Well, the leading coefficient is the number in front of the x with highest power. So the number in front of x with highest power is simply 1. The leading coefficient is the number in front of x to the 4th. Nothing fancy there. The leading coefficient is 1. And the end behavior. Okay, so end behavior can be one of 4 things. Okay, a graph can look like this, where both sides go up. A graph can go both sides down. A graph can go one side up, one side down, or a graph can go, the other 2 sides one up and one down. So when you see this are the only four things a polynomial function can do. It can either go up both sides, down both sides, up to the left, down to the right, or up to the right, down to the left. So the end behavior of this function, and it's totally determined by the leading term, okay? So the leading term. So you ask yourself, is the degree even or odd? Okay? So the degree is even. So when I say even degree, it's going to be one of these two things. Okay, so this is even degree. And these are odd degree. Okay. So if they're odd degree, you're going to go up one side, down the other. If they're even degree, they're going to go both up, both down. And then again, after that, you say, okay, well, how do you know? Well, this one is going to be positive LC, negative LC with an even degree. This one's going to be positive LC and then negative LC with an odd degree. So when I look at this particular one, I got an even degree. So I'm looking at this one or this one. And then I got a positive leading coefficient. So the end behavior of this graph would be up left, up right, or however your teacher says. I'm going to say rises left, rises right. And if that's confusing to you, practice a little bit, okay? End behavior is one of those things. I mean, for a polynomial function, there's only four things that can happen. So you have a 25% chance of guessing correct. The idea, though, is if you know that the degree is even and you know the lead coefficient is positive, you don't have to guess. You know it's going to rise left, rise right. I always relate it back to x to the second, or x squared is a parabola. Positive parabolas go up like this. Negative parabolas go down like that. All right, and then the other one, odd degree, I just talk about a line. Positive sloping lines look like up to the right, down to the left, and then negative sloping lines go up to the left, down to the right. So I think odd degree just reminds me of positive and negative sloping lines. Even degree reminds me of positive and negative parabolas. So if you can think of it like that, it applies to any polynomial function, whether the degree is 2 or 422. It's gonna look like one of these. All right.